Well, just about to start over on BBC1, Pebble Mill at 1, which today includes a look at the world of pumping iron with some champion lady bodybuilders and more microwave magic with Beverly Piper. Here on Daytime on 2 now, some more maths help with a look at equations.
Problem. Solve the equation 2x minus 3 over 2 equals 4.
What's this question asking us to do? The equation is just a statement about some unknown number that somebody has called x. And all we know about the number is that twice the number, minus 3, all divided by 2, comes to 4. And solving the equation means finding a value for x which makes the statement true. But how do we go about that? Is there some general technique for solving equations like this? Well, let's step back. One way of trying this would be to use guesswork. We could just think of a number of x, pop it in here, work out 2x minus 3 over 2, see if it comes to 4. Let's try x equals 2. Then 2x minus 3 over 2 is 2 times 2 minus 3 over 2, which is 4 minus 3 over 2, which is 1 over 2, or half. And that's no good because you wanted to get 4. Let's try something else. Let's try x equals 1. If x is 1, then 2x minus 3 over 2 is 2 times 1 minus 3 over 2, which is 2 minus 3 over 2, which is minus 1 over 2, or minus a half, and that's even worse. In fact, guesswork isn't a very good method. It's time-consuming, inefficient, and there's not even any guarantee that you're going to get the answer in the end. And so mathematicians have devised a simpler method, a mechanical method, that will always work. This is a very simple equation. It's a statement about an unknown number, x. And it tells us that if we add 5 to this number, it'll give us 13. I expect you can see straight away what x must be, but let's look at this equation another way. Here's x. It's a bag with an unknown number of marbles in it. What the equation tells me is that if I add 5 to this number, then the answer must be 13. But I can represent that physically using scales. Here in this pan, I've got 13 marbles. And what the equation tells me is that if I put the bag there with x marbles in, and I add another 5 to this one, 1, 2, 3, 4, 5, then it must be in balance. And you see, it is. And that's a physical representation of the equation. X plus 5 equals 13. But what are we trying to do? We're trying to find out what x is. Now, if I take 5 marbles out of here, 2, 3, 4, 5, I'm left with just x there, then of course it goes out of balance. But I can keep the balance by taking 5 out of this side. 2, 3, 4, 5. I've taken the same from each side. It was in balance before, so it must be in balance now. And it is. And now I've got x on that side, and I've got 8 on that side. And this is a physical representation of the fact that x equals 8. Now, that's a very simple sort of physical demonstration, but it's a very useful idea to keep in mind, the idea that equations are all about balance. So let's try to move away from the physical situation to the more abstract one, but keeping that notion of balance in mind. Let's repeat that process arithmetically. Our original equation was x plus 5 equals 13. We can take 5 away from the left-hand side to leave x. But if we do that, we must take 5 away from the right-hand side to keep the balance, the equals sign. So x plus 5 minus 5 equals 13 minus 5. But x plus 5 minus 5 is just x. And 13 minus 5 is 8. So x equals 8. Which is just what we had with the marbles. But this time I did it without any guessing, no cheating, didn't even open the bag. All I did was to keep the balance by doing the same thing to each side at every stage. Just keeping the balance. So that's got the key idea. The two sides of an equation, any equation, must be kept in balance. Whatever you do to one side, you must do to the other to keep the balance. OK, now we've got that, let's try something a bit more complicated. This one's not simple enough to see at a glance what x must be. So we'll have to approach it in a logical way and use our notion of balance to solve it. But what have we got in terms of bags of marbles? Well, we've got 4 bags and 4 loose marbles. And then on the other side, we've got 1 bag and 10 loose marbles. And this is just a representation then of the equation 4x plus 4 equals x plus 10. I'll dispense with the scales now, but I'll keep in mind the idea that I've got to keep these two sides in balance. But what am I aiming for? I want to get 1 bag on this side and marbles on that side, so I know how many marbles there are in this bag, as long as I've kept in balance. Well, what I've got so far, 4 bags and 4 marbles equals 1 bag and 10 marbles. 4x plus 4 equals x plus 10. Now, remember I want bags on this side, marbles on that side. So the first thing is to get rid of this bag. But if I get rid of that bag, I'll have to get rid of one on this side as well to keep everything in balance. Well, that's progress because I haven't got any bags on this side now at all, but I've got some marbles on this side. So let's take those 4 marbles away, and to keep the balance, take 4 away from here at the same time. Then I'm left with 3 bags here and 6 marbles there. 3x equals 6. Well, now I'm nearly there, except, of course, I've got 3 bags here, and what I really want is just 1 bag, so I want a third of what I've got there. So I'll take a third of each side. If I take a third of this, I'll be left with 1 bag. If I take a third of these 6 marbles, I'll be left with just 2 marbles. So what I'm left with is 1 bag and 2 marbles, which tells me that x is equal to 2. So I've solved the problem. I've found out that x is equal to 2. And I didn't have to use scales at all. All I really did was use that notion of balance. And I could have done that process purely arithmetically. So let's go through the steps again. 4x plus 4 equals x plus 10. So we took x from both sides to keep the equality. And that gives 3x plus 4 equals 10. So we took 4 away from both sides, which leaves 3x equals 6. And finally, we divided both sides by 3 to give x equals 2. And we've solved the equation purely by doing arithmetic. OK, so what was the original problem? Do you remember it? This was the equation, 2x minus 3 all divided by 2 equals 4. And what I'm going to do is just to apply arithmetic processes to this equation, remembering all the while to keep in balance. So whatever I do to the left-hand side, I must do to the right-hand side. And I'm going to process in simpler and simpler forms until I end up somewhere down here with x equals something, simplest form you can have. OK, so what do we do? Well, if you remember, what we've got to do is to get x's on this side, numbers on that side. This number 2 under here is sort of tying this x and this 3 together. So the first thing would really be to get rid of that 2 to get a simpler form. Now, the easiest way to get rid of dividing by 2 is simply to multiply by 2. But if I multiply that by 2, I've got to keep the balance and multiply this side by 2. OK, now let's work it out. 2x minus 3 divided by 2 multiplied by 2 is just 2x minus 3. And That's equal to, what have we got on the other side? 4 times 2, that's 8. Well, that's progress. That's looking a lot simpler already. Remember, I'm heading for x equals something. So let's get rid of this minus 3 here. How do we undo a minus 3? We add 3. So what I'd have to do here is to add a 3. But I've got to keep the balance, so I must do the same to the other side. OK, now let's tidy that one up. 2x minus 3 plus 3, that's just 2x. And that equals 8 plus 3. That's easy enough, that's 11. Now I'm nearly there. I've got x is this side, numbers that side. But I've got 2x, and all I want is just x on its own. So let's divide that by 2. And to keep the balance, I'll have to divide that by 2. And now I'm there, because 2x divided by 2 is just x. And what have I got on this side? I've got 5 and a half. So that does it. That solves the equation. I've got x equal to 5 and a half, and I've done it by straightforward mechanical manipulations. Equations can be very off-putting. They've got all sorts of nasty signs and symbols in. But you shouldn't worry about it, because any equation of this type can be solved using the 4 basic arithmetic operations. If you're trying to solve an equation, you can add the same thing to both sides, or you can subtract the same thing from both sides, or you can multiply both sides by the same number, or you can divide both sides by the same number. And as long as you remember to keep things in balance, you do the same thing to each side, then you're sure to get there in the end. Any equation of this type can be solved like that. Of course, having said that, you're bound to start making mistakes. But you can rest assured that it's very likely that if you do make a mistake, it's probably because of that one thing, that you're not keeping the sides in balance.